Let me introduce SmartRecruit, a cutting-edge application designed to transform the recruitment process using the power of AI and the RAG pipeline. In this RAG pipeline, the retriever type which we are going to implement is of two types. One is a simple doc retriever, where the entire content of the document, in this case a particular CV, will be extracted and then augmented with the user query to the generative model. And then the other type of retriever which we're going to implement is the advanced retriever, which is embedding plus semantic search based retriever. This application empowers the HR departments and the hiring managers by providing an intuitive and efficient way to search and evaluate candidates. SmartRecruit combines the latest AI technologies, as I said, including embeddings, semantic search, and of course, generative AI, to create a seamless and interactive experience for recruitment teams. This application defines how hiring managers evaluate candidates and making the process smarter, faster, and more effective. So let's see how the application looks like. So this is how the Smart Recruit dashboard looks like. So as I said, Smart Recruit is an intelligent application designed to streamline the hiring process with ease and efficiency. So user can start by uploading a batch of CVs, no matter how many you have. So let us upload some sample CVs. So I'm just uploading some sample CVs. So these CVs are now uploaded. So once the CVs are uploaded, a single click on the embed button transforms these documents into vector representations using an advanced embedding model. So here the embedding model which we are using is from the OpenAI. We will talk about that embedding model when we will do the code walkthrough. So let us click on this embed button. So here, this is the embed button. When you click on this, all these uploaded CVs will be embedded and stored in the vector database. So embedding is also successful. Now you simply type your query in the natural language, or you could also paste the entire JD or the job descriptions, and then the Smart Recruit gets to work. So maybe let us type a simple query like provide me candidates with experience over years in Python. So let's see what we get. All right. So we get one CV out of all the CVs uploaded. So this particular CV is having the relevant experience in Python as per the user query. So to see more than one CV in the filter just for the demo purpose, let me modify this query. Provide me the candidate with experience over 1 year. So maybe we may get more CVs in Python, only one. So let me further modify this query. Just provide me candidates with experience over 1 year. And there you go. So this time you have two CVs. All right. Now then from the filtered CV, which is here, you can select one and explore its content further with the app's powerful feature. So here you see when you selected this particular CV, the entire content is then displayed here. You could choose the other one, and then the page will load that particular CV. Once you select a particular CV, then you have options like download the selected CV or summarize CV. Now the summarize CV is an excellent feature. When you click on the summarize CV, it saves your time. You don't need to read through this CV content. Rather, it will give you a quick summary of the CV. The summarize CV button, as you saw, provides a concise summary of the candidates, highlighting key details like their highest education, years of experience, the current company where he is working on, and the technical skills. Now the summary, which is capturing all these details, is because there is a prompt instruction um, in the backend. We will see when we will do the walkthrough. So through that prompt instruction, the model is instructed what to be summarized as part of this summary. Then when you have any other specific questions about this selected CV, then you go and ask the specific question in this chatbot. So here you can ask, say, does this candidate have any awards or recognitions? So if the candidate having any awards or recognition, we would like to see. So then it says the CV content provided does not mention any awards or recognition for the candidate. Now let me do one thing. First, let me copy this question. I'll select the second CV, okay? And in the second CV, let me run the same query. Now the CV content provided does not mention any award or recognition. This particular CV also don't have any awards or recognition. So you could ask any other question. So this time when you are asking any question, what happens is that the entire content of the CV is retrieved and then it is sent to the generative model along with the user query to generate this part of the response. All right. All right. So when you are done with all that and you are ready with the filtered candidate which you want to move forward with, then SmartRecruit takes it one step further. So with one click of the button, you can also send the email to the candidate. So you see here there is a send email feature. It gives you a pre-populated template where you just replace the the position name, and then it gives you kind of a pre-filled uh, email body. You change these details and then you hit on the send email button. Now here if you notice, you're not providing any email address of the recipient, because what is happening in the back end is that this application is fetching the email address from the CV and then it is using that internally, so you don't need to even search for the email or type the email address. All right, so this is what the Smart Recruit does. So it's a seamless end-to-end solution that not only simplifies the CV management, but also adds intelligence and efficiency to your hiring workflow. Now let us see how this is designed, and also we'll see the code walkthrough. Before we dive into the implementation of this use case, we need to understand few concepts. Before we dive into the implementation of this use case, we need to understand few concepts. Let us talk about tokens and token limits, an important concept in understanding how language models like GPT operate. So what is a token? A token is a unit of text that model process. For most common English text, one token roughly equals 4 characters or 3/4 of a word. For example, in this sentence, I love cats and dogs, each word is common. So each is treated as one token, making a total of 5 tokens. However, less frequent or complex words might be split into multiple tokens. For example, here the prompt engineering is a new domain in ML. The word prompt is split into prom and PT. And therefore, the total number of tokens in this sentence is 9 tokens. Now, what is token limit? So different LLMs have varying token limits. These limits define the maximum number of tokens the model can process at one time. A model processes both input tokens as well as output tokens. The input tokens is the number of tokens in the input prompt, and the output token is the number of tokens generated in the model's response. So how these token limits are defined? So first of all, what is the total token? So the total token usage is the sum of the input tokens plus the output tokens. So anything exceeding this limit will truncate the input or stop the response generation process from the model. So in summary, understanding token limits is crucial for optimizing your prompts and ensuring that you stay within the constraints of the model's capabilities. Now, why we learned this concept? Because now you can understand that if you are working with a huge set of documents, you cannot send the entire document content to the language model because there is a token limit. And therefore, you need to create segments or create different chunks or split the entire document into multiple chunks, and then you operate at the chunk level rather than at the documents level. Now, as you can see from this chart, token limits in language model have been steadily increasing over the years. For example, earlier models supported just a few thousand tokens, but today models like GPT-4 can handle much larger token limits, enabling more context to be processed in a single query. But as I said, no matter how much these limits grow, there will always be an upper boundary. So this limitation is inherent to the architecture of language models. As our documents grow in size, whether it is the long reports, the FAQs, the knowledge bases, we cannot rely on feeding the entire content into the model at once. And this is why chunking documents into smaller, meaningful pieces is a crucial part of the retrieval-augmented generation pipeline. By splitting the documents intelligently, we ensure that each chunk fits within the token limits. The model can retrieve and process the most relevant chunks to generate accurate and contextually rich responses. In summary, while token limits are increasing, chunking will always remain a vital processing step or pre-processing step to make RAG systems scalable and efficient. So let's talk about chunking now. When we work with large documents or data sets, it is not practical to process the entire document at once. As we saw, there is a token limit. Now, chunking solves this by breaking down a large document into smaller, manageable pieces called chunks. This makes it easier to retrieve, process, and use specific parts of the document efficiently. So to answer what is chunking, so chunking involves splitting a document into smaller sections. These chunks are independent units that can be processed and retrieved separately. The diagram on the left side illustrates this process. So here a document is divided into multiple chunks like chunk 1, chunk 2, and so on. On the right side, we see a list of chunking techniques. So we have a line number count level chunking, then at character count level chunking, then we have a token count level chunking, a sentence level chunking, a paragraph level chunking, and at the page level chunking. The choice of chunking technique depends on your use case. Like for highly structured or small scale text, character count or token count chunking works well. For logical groupings such as articles or essay, sentence or paragraph level chunking is ideal. For documents like PDF, page level chunking might make the most sense. So to conclude, chunking is a fundamental concept in many AI systems. It ensures that the large-scale data can be efficiently indexed, retrieved, and processed in a structured way. All right. So once you understand the chunking concept, there is another concept which we need to understand is chunk overlap. Imagine you have this text corpus, and we are doing chunking at line number count, say 5 lines per chunk. So you get this. And then when we are trying to answer a question like this, what are the use cases of LLM? Then if you notice, we don't have the right information in either chunk because it is split apart. And to answer this particular question, some part of the text is in chunk 1 and some part of the text is in chunk 2. So the answer to this question lies in this part. which is crossing over two chunks. To tackle such situations, there is something called chunk overlap. The basis of all the text splitter involves splitting chunks in some chunk size with some chunk overlap as shown here. A chunk overlap is generally kept as a little overlap between two chunks, like a sliding window as we move from one to other. And this allows for the same piece of context to be at the end of one chunk and at the start of the other, and helps create some kind of a notion of consistency. Here in this case, chunk overlap is of one line. That means the first line of chunk 2 will be also be part of the chunk 1, and the last line of chunk 1 will also be part of chunk 2 as shown here. Now this question, what are the use cases of LLM, can be answered correctly using chunk 2. If our chunks are too small or too large, it may lead to imprecise search results or missed opportunities to surface relevant content. As a rule of thumb, if the chunk of the text makes sense without the surrounding context to a human, it will make sense to the language models as well. Therefore, finding the optimal chunk size and the optimal chunk overlap for the documents in the corpus is crucial. All right. So now, as we learned the concept of chunking, the chunking overlap, and the token limit, is the right time to also learn the embedding concepts. Now, embeddings are a powerful representation of textual data into numerical format that captures the meaning, the similarities, the relationships, and the context between words and sentences based on their placement in the text corpus. In the left-hand side, you can see converting text to numbers using embedding models. So there is embedding model, and you pass your text corpus. The embedding model returns the dense representation in the numerical format, which is the vector representation of your text corpus. Why this text is converted into the numerical format is because any machine learning model do not consume the textual data, they consume the numerical data, and therefore this textual data needs to be converted into the numerical representation. In the right hand side, you see the most common embedding, which includes the word embedding, where each word is embedded using the embedding model. Then we have sentence embedding, where you pass the sentence, the complete sentence to the embedding model, and you get the sentence as vector representation. The another embedding method is the text chunk embedding, where you pass the complete chunk and then the entire chunk gets embedded. Then you have the document embedding, where you pass the entire document and the entire documents gets embedded. All right. So as I said, once you have this conversion done, that means once your text is converted into the dense numerical representation, which is also called the vector representation, then you need to find a way to find the relationships between the words, the sentences, and the documents out of those numerical representation. So how to do that, right? So there are different methods, right? So like equivalent distance, Manhattan distance. There is also called cosine similarities, right? So the cosine similarities is the one which is used in natural language processing and LLM for semantic search. So this cosine similarities actually measures the cosine of the angle between two vectors. So this is the formula, how it is derived mathematically. And then the value which is close to 1 indicates that the two words or the two sentences or the two documents have similar meanings. The values close to 0 indicates that the two words or the two sentences or the docs have different meanings. So using the cosine similarities, the context, the documents or the sentences will be searched in the vector database. When these embeddings are stored in the embedding vector database, then the semantic search is performed using these cosine similarities. So let us see how this semantic search is performed for document embedding. So you have these documents. These documents first gets split into different chunks, and then using the embedding model, these chunks are then converted into embedding. And then these embeddings are, let's say, plotted into n-dimensional vector space. So using this numerical representation, they are plotted into n-dimensional vector space. So they have taken some place in the n-dimensional vector space. So how this vector representation is used in the real use case is that when there is a user query, so the user query is also first gets converted into the vector representation and then plotted into same n-dimensional vector space. This is also done through the embedding model. So the query will also convert it into the vector representation using the same embedding model. And then the semantic search is performed. So this query vector is compared against each and every chunk in that vector database. And then the closest match is picked to generate the final response. All right, so we have covered the basic concepts which we wanted to learn before we actually, dive into the implementation of our smart recruit use case. So in our smart recruit use case, as I mentioned in the beginning, we have implemented two retrieval types. One is the simple doc retriever, and another one is embedding based retriever. So let us try to understand first the simple doc retriever which is implemented. So here we have a retriever, a generator, and then we have the external knowledge source. The user submits a query. The retriever accesses an external knowledge source, such as a document, in this case, a particular CV, and retrieves the entire content of that document. So in this case, it retrieves the entire content of the filtered CV. And the retrieved document content is then combined with the user query and sent to the generative model. The model processes the combined input, applies the prompt instruction, and generates a detailed and relevant response. So this part of the code, where exactly this is used in our smart recruit is, you remember there was a summary button where once you selected a particular CV in the left-hand panel, then you click on the summary button. So that time the entire content of the selected CV is retrieved. Then it is sent to the generative model with the prompt instruction that summarize this particular CV and you extract this and this content from the CV. That was one path. And then another path was that when you have selected the CV, then you ask the follow-up questions specific to that CV. Say, I want to know if this particular candidate have won any award or recognition. Then that also goes through this retriever type. Finally, the generated answer is returned to the user. So this was the simple doc retriever, which is part of the implementation. The other retriever type which we have implemented in our use case is embedding based retriever. This slide explains that part of the logic. So we have a pre-processing unit, then there is a retriever, there is an answer generator, and there is an embedding models, and there is a generative model. Now the process starts with a set of documents, which is the set of CVs. These are divided into smaller chunks for better retrieval accuracy and to maintain, that we are still into the token limits. Each chunk is then passed through the embedding model, which converts this text into a numerical vectors called embeddings. The embeddings are stored in a vector database for efficient retrieval. Now, when a user submits a user query, it is also converted into an embedding using the same embedding model. All right. The query embedding is then compared with the stored embeddings in the database using cosine similarity to identify the chunks which are most relevant to the user query. The system retrieves the best match chunks, like the retriever part of the pipeline retrieves the best match chunks. In this case, say chunk 2 and chunk 5 is the best match chunk for this user query. So these chunks are returned by the retriever. And then these chunks along with the user query are sent to the generative model, which processes them to generate a coherent and contextually accurate response. So finally, the user receives the answer in the natural language tailored to the user query. So this is how the second retriever type, which is embedding based retriever, is implemented in our use case. All right. So now as we understood the design of this use case, let us go through the code. So as always, we are going to import some libraries. So let me quickly walk you through these libraries. So Streamlit is a library which provides a framework for creating interactive web applications in Python. Then we have this zip file. This zip file handles the creation, reading, and extraction of the zip files. Then we have this OS, which offers utilities for interacting with the operating systems like file path, environment variables, etc. Then we have this docx. Now, this docx reads and writes the Microsoft Word files in the docx format. Then we have PyPDF2. The PyPDF2 processes PDF files, enabling text extraction and manipulation. Then we are using LangChain libraries, which is again an open source library. So here you see the set of libraries being imported from LangChain for different purposes. So I can quickly walk through one by one. So the first one is Chroma, where it manages the vector storage and similarity search in a vector database. Here we are going to use the Chroma database. So LangChain has a wrapper on top of Chroma DB, which provides you kind of the vector store and similarity search functions. Then we have this embedding. So we are using embedding from OpenAI. So this langchain.embeddings.openai generates vector embeddings for text using OpenAI models. And then we have LangChain schema, which represents a structured text document for processing the LangChain. Then we have this recursive text splitter. Recursive text splitter splits text into manageable chunks for processing. Then we have .env. Now this load underscore .env loads environment variables from a .env file into the application. And then we are going to import the OpenAI libraries because we are going to use OpenAI APIs. This JSON handles the encoding and decoding of the JSON data. Here we are importing the regex library, which provides tools for pattern matching and text manipulation using regular expressions. We're also importing SMTP-lib. This library enables sending emails via the SMTP protocol. And then we are importing MIME text, which constructs plain text email messages for sending via SMTP. Once the libraries are imported, we need to load some of the environment variables. So the important ones are the first of all, we're going to load our OpenAI API key. Now there is a .env file. In this .env file, you need to configure these variables. So you need to configure your OpenAI API key, then SMTP server, port, username, and password. Now here from that .env file, we are reading our OpenAI API key, and then using this OpenAI API key, we are initializing our client object to access OpenAI models. So using this client object, we should be able to access the OpenAI APIs, and through that, we should be able to access the OpenAI embedding models and the generative models. All right. We are creating 3 directories. One is working underscore CSV, then one is embedding, and one is chunks. So working underscore CSV is the directory where the CVs or the resumes, once they are uploaded, will be kept. And then when user clicks on the embedding or embed button, the chunking and the embedding happens. So chunks are stored in this chunks folder, and the embedding will be stored in this embedding folder. All right. So now here we have a couple of helper functions. So these 2 helper functions are to extract the file content from .pdf and .docx file. So because our resume are going to be in .pdf or .docx file. So this read underscore PDF function handles the extraction of text from PDF files using the PyPDF2 library. So how it works? So basically, PyPDF2 dot PDF reader is initialized with the file object. So this file object is passed, and this PDF reader is initialized, which allows the function to access all pages of the PDF document. It then iterates through each page of the document, calling extract underscore text to retrieve the text content. All the extracted text is appended into a single string, and then it is returned. Okay, and this is just the error handling part. Now let's move to the read underscore docx. Now this one is designed to extract text from Microsoft Word documents. So using document class from the Python docx library, the Word document is loaded. The function loops through all the paragraphs in the document. Okay, and then it extracts their text and then join them with line breaks. Just like with the PDF function, it handles potential errors gracefully by returning an error message. Together, these two helper functions forms the backbone for document processing in our application. They ensure that regardless of whether a user loads a PDF or Word file, we can efficiently extract the text content and process it further in our pipeline. All right, let's move further. So then we come to our generator module. So this is the response generator. So this function generator takes two input. One is the user query, the question posted by the user, and the context, the full content of the CV that serves as the background information for answering the user query. Its purpose is to generate a detailed and accurate response based on the query and the context. Now, there is this prompt instruction. So this prompt instruction instructs the GenAI model on how to respond. So it begins by defining the role of the AI so as a helpful assistant, and then provides the CV content as a context, and finally appends the user query. So here we are going to call OpenAI API through our client object. Then we are configuring our model. So we are going to use GPT-4 Turbo model, and in the message list, we are going to pass our prompt instruction. We are using temperature 0.2, and then we are going to get the response from the GPT model, and this function will eventually return the response. All right, let us move next. Now we have this summarize underscore CV function. If you remember our application features, there's a feature to summarize the CV. So once user filters the set of CVs, and then from the filtered CV, user can select a particular CV, and then there is a button called summarize. So when user clicks on the summarize button, so this function is invoked. Now in this function, you see it takes the context. Context is nothing but the content of the selected CV. Then there is a prompt instruction. In the prompt instruction, it is stated or instructed to the model that you are an AI assistant. Below is the content of a CV, and then the content of the CV is provided. And then the instructions are like summarize this CV in a few lines, capturing the following details. So like capturing the highest education, number of years of experience, current working company, and key technical skills. So these are the elements or entities this summarized CV will extract from the CVs. You can keep on adding more entities which you want to be extracted from the CVs. You may like to have, let's say, the phone number or the email IDs. So those were also extracted as part of this summarize CV function. Once the prompt is defined, then we are going to call the OpenAI API using our client object. And here we are going to again use GPT-4 Turbo model. Then in the message list, we are appending our prompt instruction as part of user prompt. In the system prompt, we are just saying that you are a helpful assistant that summarizes CV content. So we are setting the tone or kind of a role for the model. And then whatever response we are going to get, this summarized CV is going to return the response, and that is the response which gets displayed on the dashboard. All right. Now we have extract email function. So this extract email function is designed to locate and extract an email address from the given block of the text. So in this case, this is the resume or the CV content. So inside the CV content, it is going to look for this regex pattern, and then it is going to retrieve the email address. So, and then if the match is found, then it is going to return the email address. All right. Now we have this send email function. Send email function takes care of sending an email to a recipient. Here, you see, here we are just extracting this configuration from our .env file. So SMTP server, then the port, username, and the password. And then here, MIME text is basically formats the email body into MIME compliant structure. So it sets the subject and the sender and the recipient to the email. So this is what is done here. Then this smtp live.smtp. So this line of the code, this line opens a connection to the SMTP server and secures it with start TTLS. And then it logs in to the server using the credentials like the user and the password. And finally, it sends the email using send email and confirms successful transmission. Okay. And then this is the error handling part of the code. Let us move further. Now, this process and embed CV. So this function process and embed CVs is the backbone of preparing CV data for semantic search and retrieval. It processes uploaded CVs, splits their content into manageable chunks, and then converts the chunks into vector embeddings. So let's break it down step by step. So the function starts by iterating through all the files in the working directory. Okay. Each file is identified and its format is checked, either PDF or docx. The corresponding helper functions like read_PDF or read_docx, which we defined earlier, are called to extract the text content. Once the text is extracted, the next step is splitting it into smaller chunks. Now, to do that, here we are using recursive character text splitter from LangChain. Now, here each chunk is 1000 characters long with a 100 character overlap. All right. So then we get our chunks here. Once the chunks are created, this part of the code creates the document object for every chunk for embedding. Now, the document object contains two things. The number one is the page content, which is the actual text of the chunk. And then it contains the metadata, which is the information about the source file, like its file name. So let me show you how this documents may look like. So this is how the document object look like. So here you see it has two parts, the page content and the metadata. So these are actually two chunks of a same CV or the same resume. And then when it is converted into document object, this is how it looks like. All right. Now, once the chunks and the document objects are created, they are stored. So the chunks are stored as .txt file, and the documents are stored as .json file. All right. Now, once the chunking and the document objects are created, then this function creates embeddings of those document objects or the chunks which were created, and then it is calling this function, chroma function, where you basically provide the persistent directory path, the path where the embeddings will be stored, and the embedding function. So here the embedding function is this one. So we're going to use text embedding 3 laws from OpenAI, and then this db.add underscore document, those embeddings are stored in this location. Okay, so until now we have pre-processed our CVs, the uploaded CVs. They are chunked, they are embedded and stored in the Chroma vector database. Now this is the main Streamlit application, the front-end part. So here it is just the layout of the page is set, and then you have the title. So this part of the code defines the left panel where you have options like upload CVs, where you could upload CVs in .pdf or .docx form. So when the CVs is uploaded, it gives you the message like the CVs are uploaded successfully. So the uploaded CV is kept under this working folder, which you defined above. Then in the left panel, after the upload CV, we have embed button. So once the CVs are uploaded, a user can click on this embed button so that it will call this process and embed underscore CSV function, which will take care of going through those uploaded CVs, chunking them, and then embedding them, and then storing that into Chroma vector database on the provided path. After the left panel, now we come to the main screen. So on the main screen, we have this header query CVs, and then we have this text box where user types the first query. So you could copy paste your entire job description or ask a specific question. And then when there is any user query, then the first thing it does is that it tries to do the similarity search. Now it calls the db.similarity underscore search function. This similarity search function takes the user query and it first converts that user query into the embedding vector. And then once the query is converted into embedding vector using the same embedding model, then semantic search is performed between the query vector and the embedding which was done for the CVs. So top 2 best match results are actually returned from that semantic search. So that is what, based on the search result in the left-hand panel under the filter CVs, you get to see the list of CVs which was filtered as part of this similarity search. So once a CV is selected, then we need to read the content of that CV. So CV could be in .pdf or .docx form, and therefore it calls the respective helper function like read underscore PDF or read underscore docx. And then the content of the selected CV is read. So that content is now available into text underscore content. So the CV content is also displayed on the main screen. So if you noticed, so when you select the CV on the main screen, the content of the CV is also displayed. After the content of the CV is displayed, there are two options. One is to download the CV. So there is a download button through which user can download the CV. And then there is also a button to summarize CV. So this summarize CV button, when you click, it calls this summarize underscore CV function, which was defined earlier, where the content of the CV is passed, and there is a prompt instruction inside this summarize CV function, which calls the language model, the GPT-4 Turbo model, to summarize the CV based on the prompt instruction, and the summary is then written on the screen. Then user can ask the follow-up question. So there is another text box where user can ask the follow-up question for the selected CV. And then there is this generator. So this generator is the generator part of the workflow, which takes the user query and then the content of the selected CV, and then calls the language model, and the language model provides the response back, and that response is again written on the screen. Then this extract underscore email function extracts the email for the selected CV, and that email is then used, the email address is then used to send the email to the selected candidate. Here there is again a text box for sending the email where there is an email subject. So there is a pre-filled option there. You can edit that. Similarly, for the body, there is a pre-filled text which you can edit. And then finally, you send the submit button. Then the submit button calls the send underscore email function, which is defined above using the email address of the candidate, and then the email subject and the email body. And then the status of that is written on the screen. All right, so this is all about it, the code walkthrough of our SmartRecruit use case. So now I will talk about how to create the setup of this use case. So here, this is the code repo on GitHub. On GitHub, you can, just go on this page, DataScienceChampion and Zero to Hero in NLP, LLM, GenAI, AGI. And here you try to either clone the code repo using this URL, or you can directly download the package, the whole directory. And when you download that directory, so you have to go inside this RAG folder. In the RAG folder, you have this SmartRecruit use case. So you will have this. Under that, there is a README file. Okay. So you need to follow this README file to create your setup.